Okay. We're going to have the introduction into SDC Verifier 5.3 today. Together with me here is also Jarko Jurečko, who will show the new features. I see that Wouter has also joined. You're free to unmute your microphone at any time for, suitable for you, and ask your questions. Interrupt me, feel free to interrupt, or just type in your questions in the chat box and we will reply to them during the Q&A session. I would like to make a brief introduction into the agenda of this meeting. So I will make the introduction into SDC Verifier software. We see that a lot of you already are familiar with our software, so you already know what it is, and we had quite a lot of discussions about SDC Verifier, so I will keep it as short as possible. If you haven't seen the introduction into SDC Verifier, you can check our previous webinars or just ask me to give a dedicated demonstration. So after the introduction, Jarko will show the features which will be available in new version of SDC Verifier 5.3. Also, we will show you what are our future plans, what do we plan to develop in 2020, and we will highlight some features that are already almost available, and also the possibilities to learn more about SDC Verifier now or in the future. So let's start. This is a standard SDC Verifier workflow, the circle, which describes the procedure of the code checking and finite element analysis and post-processing of the finite element analysis within our software. So SDC Verifier is the powerful post-processing tool which performs code checking, reporting, load combinations, some other small features within your FEA model, which is built on Ansys, FEMAP, or SimCenter 3D. So modeling still has to be done by you. And, so we take your finite element model and results from your finite element model. Next step to perform the successful code checking is load combinations. We are capable of creating huge amount of load combinations with safety factors, with partial load factors, based on superposition, positive, negative, and so on. Then we can do the recognition of the structural members, because checks are not done on the finite elements, it's done on the structural members. So we do recognize some structural items within your model. I will have a short slide on this. Then we have the checks. A lot of codes are implemented. Some of them will be added in new versions. We have the plans for future, and you can write your own. And of course, complete automatic documentation, which describes everything, how your model is built, what are the loads, constraints, boundary conditions, results of general FEA, results of checks, and much more. So this circle, and the biggest benefit of the circle is that the procedure is stored. So if you have to modify something, you just update your model and generate the new report within SDC Verifier. So few words on the load combinations. It is easily possible to create any amount of loads you want. You can create the pattern within our software. You can create the pattern within Excel sheet, for example, and then paste it. Amount of loads can be huge, and it helps you to verify your structure within all these combinations. Short introduction into the structure of our calculation core. We have individual load, which is single load results from your FEA program. Then we are capable of creating load sets, which are linear combination of loads, where we have a possibility to add factors, also make it positive or negative, and so on. And then we have a load group, which is an envelope set of results if you would like to see the overall maximum of few load sets or few individual loads or even few load groups. So it's also possible to create group of groups. Next step is recognition. We can recognize structural members within your model. So this can be the joints or the beam members to determine the type of joint for the future joint checks or the member lengths and member parameters from beam buckling. This is how the structure looks within the recognition of joints. Then we have the recognition of sections and plates, and from now on we are also capable of recognizing the stiffeners to perform the plate buckling check, to perform the stiffener buckling check, and also we can recognize the welds. We are able to reorient the stresses and forces into the weld direction or perpendicular to the weld. You can recognize the weld intersections, set for it the dimensions of the weld for weld strength check, or the FUT classes for SNSURVs for fatigue calculation. And the biggest benefit of it that it is mesh independent, so you can have the very fine mesh with a huge amount of elements for your general FEA, and it doesn't depend how much elements you have. Your recognition will be precise and you will have the structural members ready to perform your code checking. Recognition is extremely quick. For 1 million finite element model, recognition of all welds takes about 30-40 seconds. If your model is smaller, it's almost immediate. When we go to the checks, I will introduce some checks that we already have. We have some checks for beam members, joints, and lattice structures. This is the IASC code, Eurocode 3, API, ISO, and NORSOC. So we're capable of doing the joints checks and beam members for check the beam members for buckling. And we have the fatigue. For fatigue, we now have the FEM code, Eurocode fatigue, DIN 15018, and of course EN 13001, which was added in the previous version. And we have a plate and stiffener buckling where we have ABS and DNV plates and stiffener buckling. Also, there are some custom checks. There are bolt checks, rivet checks, and of course, all the checks are open. So you can see the formulas of your check. You can see the description. You can see where it was taken from. So if here we have the AISC code, we have the description from which table, on which page of the document, from which formula this calculation is taken, and how this calculation is done. Also, you can copy this check as custom and make some modifications if you want to raise the safety factor or if you have some specific needs. You can modify this, and of course you can write your own. So the idea is that you can use the results of your calculations, properties of your models as parameter for the formulas and write your own checks. If you have some Excel sheets, if you have some hand calculations, which you of course are capable to do for one member and one load at a time, we can automate it for complete finite element model and huge amount of loads and any amount of combinations. General idea, also the report, almost forgot the reporting. Reporting, well, nobody likes to do the reporting. It's routine task somehow. So we have a complete template-based reporting, which will describe how your model is built, what are the properties, for example, which will describe the results of your calculation and your code checking with plots and tables. There is a huge amount of customizable tables. You can show expand values, extreme values over a certain components or overall maximum and so on. And it is all template based, so you can automatically generate a 300 pages report without need to print it. You can easily navigate through the templates, through the loads you've created, through the standards you've done, and to see the complete structure of your report in the bookmarks. So the idea of SDC Verifier is load combinations, recognition, checks, and then the complete reporting. So as a summary of this extremely short introduction, I would like to say that SDC Verifier is a tool that enables code checking in finite element analysis programs. We have a lot of popular standards available. We are constantly developing this database. We are adding new features. We are giving the possibility to write your own standards. All the formulas are open, so you can see it, you can copy and modify it, password protect it, and learn how the calculation is done. Standards can be customized, and the total calculation procedure is saved, what helps you to track the design changes, what helps you to compare different calculations or perform the same calculation routine for different models. Extensive automatic template-based reporting helps you to present your results quickly, in convenient way, and in the most broad and extensive document within a few minutes for small reports or about an hour of preparation for a bigger one. In the end of this session, I will also show you the future updates, but now I would like to give the floor to Jarko, and he will present he will show the things we prepared for today. This is why we've gathered to show you what's going to be added in SDC Verifier 5.3. So I'm changing your role, Jarko, to presenter. Yes. Now you should be able to share your screen. Meanwhile, if you have any questions regarding the introduction, maybe you have some suggestions, you're free to ask. Otherwise, we will go to the demonstration.
Yeah. Hi, everybody. So today I'm going to show you what's new in SDC. So I have prepared a presentation where at first I have the content, what was done, the major improvements and most improvements. So I will briefly go through them, and then we go one by one. Some of them I will show you in a presentation, and some of them I will show you live in SDC. So the major improvements we have in this version is integration into Ansys. That's for Ansys users only. So we already have the similar feature for FEMAP user. It's called embed mode, where you have your tree into FEMAP. And now we have the same integration into mechanical tree. Now SDC has the separate tab in mechanical with all the options, and also all the data is stored in a tree. There is no separate window. And starting, you have to have, of course, Ansys version 2019 R2 and R3, because only from that version that possibility was added by Ansys. So, the latest version has to be installed to be able to use that mode. We are going to support as well the standalone version, which was in previous version, that you can have a separate window like this. So you can work in a separate window, or you can choose and work in an embed mode in Ansys. Also we did implement two standards. So the major one is the Stiffener buckling according to DNV 2010. For that, we had to upgrade our recognition tools like Panel Finder. We have added additional tool which recognize effective plate widths. Also, we are going to add Eurocode 3 Part 1 to structural fire design in beta for this version. For the checks, we also we had added the punch and shear check in API standard. And we have few improvements for the recognition tools like Beam Member Finder, Weld Finder. Also, we have added one more tool, Beam Section Recognition, which will be handy for the reporting. And we have a few more improvements on the post-processing, like labels for your plots, automatic highlight. Those features I will show you live. And also we have some changes to your tables. We have added filter and sorting options and few small stuff, which I will show you later. So the major improvement, as I already mentioned, is integration into mechanical. So I'm going to show you how it looks like. So you have a separate tab, SDC Verifier, where you can add the standards from the toolbar. And also you have in the tree, you have the node of SDC, which basically copy the structure which we have in the main window. You have model, recognition tools, job standards, post-processing, and reports. And simply when you have a constant menu of the mechanical, you can add and you get a window from SDC. And if you add, you get a new component. You can work with it from the mechanical itself. And same for the load combinations. You can create multiple, you get a window to make a combination. So as it was before, but only now everything is integrated. We spend a lot of efforts on it because we got a lot of feedback from Ansys user that it's much more convenient way for them will be to work with SDC. Okay, let's move to the next subject. Also, we have added the modules in this version. Now it will be possible to rent one module or a couple of them in one license for a year. We have five modules: this beam buckling, fatigue, plate buckling, weld strength, and reporting module. For the Ansys user, they will be also available in the Ansys App Store and can be purchased from there. And alternative option is for FEMA Instant Center user to order the license and include modules they want from us. And now we can go to the checking part. So we have added the buckling check into the DNV. I think I will do for this one. I will make a demonstration. So I have prepared a small project. All the demonstration will be held in FEMAP. We are supporting 3 systems, but I'm going to show that in one. So I made very simple model to make a demonstration. So to add a standard, you simply follow as it was before. You go to the standards, add DNV 2010, and for new options were not added here. Actually, for Stiffener buckling, you simply press OK, and you get 2 new checks. Here we have some calculations required to calculate limits because the Stiffener buckling check is quite complicated. It's around 100 parameters, and the results you have in the last check. Show you it's around 59 calculations, and what we have to change, it's the panel finder tool at the first place, because before we did recognize only plates. Now we are recognizing panel, plates, and stiffeners and girders. Also, we had to change the panel finder, so I want to show you that's on an example. That was the old tool. Before you had for each section the separate list and the custom section, which was inclined section, plots, export. Now panel finder is simplified a lot. Although we have added the plates and stiffener, the look is much simpler. You have one list of all sections. Here you have you can display panels, plates, or stiffeners, as I showed to you. And also you have a filter tab now where you can choose to show the plates from one section. So you can change your selection and say, I want to have the plates only from that section, or any group or name selection. I have only one in my model, so I apply, and I get panels, or I can get the stiffeners. So list of stiffeners, I filter, and here I can do the modifications. So that's about the panel finder. It was redone a lot. It was simplified. We put all the options, plotting options, here into the menu. So you can do filtering here. You can show plates, panel, stiffener as you want. And you can make, let's make inner colors. And I use a plot. I have 3 stiffeners with that belongs to section 1, 1, 2, 3. So everything now is rearranged and organized a bit differently and much simpler. But the main improvement is that we recognize more items like plates, stiffener, girders, and panels. One small feature we have added here, I think I will move a bit the screen to show you. we have added the highlight options. Now you can see, so here I have a list of stiffener. These options, when it is on, if you click on stiffener, it's highlighted immediately in CMap. This highlight options is present everywhere in the tables, in all the recognition tools. So you don't have to press, before you had to press a preview button each time to see something. But if you have two screen, like I do have, so when I click, it changes with yellow, it highlights the selected stiffener. So this automatic highlight feature, if I want to turn off, so it doesn't bother me, but you can use that in all the result tables. I will show you again one more time later. Also, what we have added in a panel finder tool, now you can do the parametric definition for the stiffeners. That's for the plates, sorry. You have two plates and you have some dimensions. If you do not want to model the stiffeners, you can choose the plates and say how much stiffeners do you have along the length and width. So I will show you how to do that. For example, I have two stiffeners, and for both of them, I want to set that I want to have 3 stiffeners and 2 stiffeners along the width. And what we have added, that you can visualize that. You have an option draw stiffener along the length and width, and it displays for you the draw object. So that's my stiffeners. Show you also the elements. So as you can see, it draws them, although it's on the middle of the element. So, and the plate buckling will be run on the dimensions done by those stiffeners. So you can quickly decrease the dimensions of your plates using this method, and you can see them on the screen. As you can see now, the dimensions are lower. It was 2 meters by 60. Now it's decreased, is divided on amount of stiffeners I have added parametrically. One more options we have added to the panel finder, it's we have added options to recognize dimensions according to common ship rules. For irregular geometry, if it's not perfectly rectangular shape, and for triangles there is definite methods. So if we go to options, there is an option to do the calculation according to that method, differently than we did before. So user has a choice for that. So the next step, because when we did the recognitions, we have all the parameters and the girder length. If it's possible, we recognize that. If not, user has the possibility to change that as a torsional length and the length of stiffener. Usually, we do recognition. If user wants, he can manually set the values. But the one more thing, what was required for the calculations, is to calculate the effective width of the plates connected to the stiffeners. The complexity was in that it should be calculated for each load case because it depends on the result. So we have added one more tool, which calls effective width. Find my plates again. Okay, I have stiffener, and below the stiffener I have connected plates. So I have, for example, for this middle stiffener, I have 2 connected plates, and for each of them I calculate the effective width, which calls SE. Here we see the stresses we calculate for plates, and this procedure we did completely open. We have this button information, and when we press it, you can see the details of the calculations, complete details. So here you can see what plates dimensions are. We calculate lateral pressure, and you can see elements. We get the shear forces and the formula how we do that. And as well, we got a lot of questions from the customer about showing the stresses. How do we calculate it now? We show how we average stresses on the plates. So you can see here a history of all elements, their stresses converted into plate direction and average. divided by area, averaged by area of the plates. And here you can see the numbers which are used from the plate stresses, from the elements. They are converted to average plate stresses, and you can see here the summary. But and later you see the complete calculation of the effective width. So all the formulas with reference to the standards are shown, the formula and the values, and the result. So you even can copy from here to Excel this part and see what the same value. So we decided to make it completely open, and this procedure I will show you we make available as well for all our calculations, because we get some question from customer how it is calculated, what are the details, was sometimes hard to figure out. You need to do some manual calculation. Now I think I will show you immediately in an example. While it's calculating, I will see this is calculation details for the Stiffener backwing check as well.
I don't know, Jarko, if that happens only to me, but your screen is updating a bit slow, and sometimes I miss what you click. But yeah, just try to make it a bit slower if possible.
Okay.
And highlight where are you clicking. But yeah, maybe it's only my issue. If anybody else has the same issue, please write it into the chat.
Okay. So I have displayed the Stiffener check table. So it's also special table where it shows list of stiffeners for me with all the results. And as I mentioned, we have this button I on the right bottom corner. If we press it, so it shows me all information about the checks, which check I am doing. I build the table on an envelope, but my results, the worst results, are on the load set. It is calculated on element 1 to 7 and with the property 1. And also I have characteristics here shown for stiffener, what are the dimensions, area, which is the type of the stiffener, to which section it belongs. And the same as for effective widths, we have some details of calculation. What are the axial forces, shear forces, lateral pressure, calculation of weight stresses, and all the formulas. Same logic, you have a formula, you have values, and the result. So you can follow the complete procedure. You saw there are a lot of calculations, and the very important thing is here we have the replacement in the checks, which you don't see in the tables. In my table, I have 15 parameters around to show, but here I have all 40 or 50 parameters shown. And in the end, you see the result of utilization factor and how it was calculated. So complete openness to the engineers, not a black box at all. And also, as I mentioned, we have this button highlight. When you click on here, and you can see in a program, it highlights where my stiffener is. So if you see, actually that was done based on some feedback from our customers. So you don't have to click preview. You can, if you see some bad results here, which does not pass, you can immediately click and see that in the model. And also what we have done, we have improved our tables for filter options. Now you can choose any parameter and define the value to filter. For example, if I want to filter my utilization factor, let it be 0.3. I can see that I have only one plate which match that criteria. And if I want, I also can sort my table. So I can choose a parameter. Before it was only automatically sorted by utilization factor, and in descending order, the highest value was on the top. If you don't want to sort the values, you can set that to none. If you want, you can choose any parameter from the list and choose the sorting order. That was the improvements for the post-processing. Also, what we have changed before, you can show plots and tables. You had to choose from the list. So you could choose only the section Y or Z, Now you can say, I want to see my on the material, for example, and it will show automatically for you all the sections which are on that selection. So you can choose a group of elements, and SDC will make a list of sections to show for you. So now it's not limited to the list of sections. You can do any selection in all the checks. So we have changed our tables to use our selector instead of list of sections. So, and for the plots, we did small improvement for the plots because we got from customers, sometimes they don't want to see the full table. For example, if I choose now the part of my model to show for plate buckling, I will see that model. So because before it was the full section. So if you are interested in some zone, you can plot that zone now for any checks for plate buckling, stiffener buckling, and weld. So this what I have showed you with the filter and sorting. It's available now in all tables, plate buckling, weld tables, so you can filter your welds based on criteria of failure. Okay, so now I want to also tell you about the new standards we have implemented. So we have implemented Eurocode 3 Part 2. This is structural fire design. Today I'm not going to do demonstration, but it will be included in 3 weeks in our release version as a beta option. So it means we will check calculation, but we do not do verification on a lot of examples. It will be done for the next release. Also, we have implemented the punch and shear check in API WSD. We get a lot of customer requests for that check, so it is part of the joint check of API standard. It's available now. And now I want to show you a few examples of post-processing because we have added label options for all the plots. Here I made an example. Let me show you how it works on my plot. In every plot you have labels options, and when I click edit, I get that window where I can choose what labels I want to show. For my stiffener check, I can say I want to see stiffener results or min-max result. So let's see stiffener 1. So when I plot, you can see that our plot is for stiffener is dedicated because we use the maximum utilization factor for stiffener, but we also show that on the half of the plate. So we split plate on 2 parts because when you will plot only the beams, can be sometimes can be hard to visually see this. So we also put that on neighbor plate elements, the results. And also labels are on top of each stiffener. So it is possible to limit if you want. You can say, I want to have this above maximum 0.3, for example. So you don't want to see all the utilization factors. Usually you can put above 1 to see only the failure ones, but I limited that you can filter and you can make your plot cleaner. And also you can show the maximum or minimum options. And besides that, we have added the possibility to plot coordinates in your picture from Panel Finder. I will show you on this example model because here I have defined that I want to see the labels coordinates from section Y in this axis and section Z. And also I have defined that I want to see only every second label. So I skipped some labels because it was too much. We saw a few examples from our customers that it helps them recognize where they are on the plot. So this is very handy for ships, for decks. If you make a deck plot, you can use labels to see where you're close to what section you are, what frame, what deck. So you can combine this one. I shown minimum and maximum results on my plot, and as well I have added here the coordinates of Panel Finder. So automatic highlight, as I mentioned, works in all the tools. In Beam Member Finder, Stiffener Finder, and Weld Finder, if you click on item in the table, result table or recognitions, it's highlight you the item. Okay, now I want to show you some improvements for Joint Finder and the Member Finder. For that, I will open different model. This model from our tutorial. So what we have added, first improvement is we take into account constraint. Before, the model where you have nodes with constraint was recognized as free joints, which were not taken into account. Now, as you can see, where you have a constraint, if you use that option, it options in the setting of Joint Finder, it's not anymore a constraint. So I will demonstrate that one. I will remove all my joints. My option is on. I find it. I plot it. You can see here I have my constraint below in 6 points. It's not anymore recognized as a joint, but if I, for example, turn off this option, if by any reason you don't want to treat them as fixed, and find, remove all, plot again. You see the bottom nodes are recognized as free joints. As well, if you will have a joint added somewhere in the middle of your model, it can be combined with a connected beam. So, for example, if I will add joint here, it will treat that not a 2G joint but 3D joint. So it's not treated only from fixed to non-fixed, but it is taken in recognition of the type of the joints. Okay, and what we have added few visualization options for Beam Member Finder. So when before it was possible to plot only IDs of the sub members, so the best I will show you. It was possible to make this plot, but if I make a full model, it's a bit too messy. And for reporting, it was sometimes more handier to show only the IDs of the parent member, Beam member 1 and 4. And I will show you how it looks like. So only this, and when you do reporting, you can show only the parent nodes and you see the location. It's especially handy when you have a table with results per member. You can make a picture and show the location of the member. So to simplify your plots, to show less labels. And we have added as well one more options to show the local beam Y and Z axis. As you can see, here with the purple is Z and green is Y axis. For each member on the center, it shows you what is the orientation of your member. And one last final options we have added. You can combine your members. It is possible only for members which have common end. So here I have common node. So you cannot completely different members not possible. But if you press combine, it shows you members 1 and 4 are merged. And if I highlighted this member, it shows me now this member is treated as one. It's not very good example because you don't do that in reality, but they are neighbors, so it's possible to combine, and the member of this will be sum of those two lengths. Okay, that's I think with Beam Member Finder, that's all the improvements. We have added one more tool. It's recognition for sections. It's basically similar to Panel Finder, but it groups beams in a planes. So, show you have in a recognition, you have Beam Section Finder, it calls. The purpose of this tool is mostly for reporting. So if I press find, it finds for me, for example, I will make a picture of in X direction of the sections. And if I want to make a report, for example, I can make quickly plots for this, that, and that one section. And also it can be handy if I want to have a detailed report per component, so I can show all the members and their results for each of that components. We have added some improvements and to our selector tool. Which is, yeah, I'm going to show you that now because it's on the end. So if I make a table, for example, and I want to see the stresses of my members, for example, okay, I haven't stored. I will recognize again. Okay. When I make a table, component table, so it will show me stresses over my members, and I can say I want to see that on a section which is I will preview to you to show. Is for example all members which are on top Z in my model. So, and I can quickly add that in my selector by a command list of my members, and if I show that, okay, I need to analyze this model. I don't have results, but it will show me stresses for all my members. So this tool is very handy for reporting purpose. Weld Finder. So I need to have. We also did some improvements for the welds recognition. Now it is all the settings are under the settings button, and most important, we have updated our filter, which looks like in Panel Finder. Let me open the model and show you. So it's now is updated. You choose on what selection you want to see your nodes and some rules by which to filter them. The very important, let me show you, I prepared an example because we have added the possibility to draw the weld in the VMAP, Ansys, and Center. So if we apply, I have the list of the welds, and I have defined for them already a type. This is a filled weld with some dimensions, and I want to plot them in VMAP. As you can see, my filled weld is drawn with the grace triangles along the weld. So if I, for filled weld, I can turn on thickness. As you can see, it draws in that position. So you can now visually see your weld in your model. If we go back to my example, you can draw, and it's physically, if we have double full penetration weld, it's drawn it, but you need to turn off thickness to see them well, because it draws in actual position where it should be, and also double partial penetration. All the dimensions you input, you can visualize your welds now in the model. Okay, and we have also added a tool for load combinations. We had that before, but we can even see that now. We had two different tools. If you wanted to create, you had a separate window. If you want to edit, it was a separate window. Now we combined it in one tool. So you can see the loads you have already, and you can add at the same time. So it's a bit simpler if you want to copy from existing and do some changes. And we also have added small tool to add factors by diagonal. So if you press that, it will start from the left top bottom and put factors diagonally. So small improvements to the load combination tool. I think I have also, we have added the property plot tool. So you can go to your model, to the properties tab, and say, open the model back. I will go back to my model with beams. Okay. I have property plotter. So I select which properties I want to see. And I have some options which defines what I want to show, only ID or title and some position. Show you how that works, how that looks in FEMAP. So it makes for you with different colors, purple, yellow, and dark gray. So gray, light gray colors, it's elements that are not selected, and rest are with colors of the property. So we choose colors which are very different for you to easily capture which color is what property. So you can use up to 16 colors on your selection, because more it's hard to recognize. And also, if you want, you can only show the elements which are in the selection, only those. So you can have an option to choose how to display it. Small improvement, but it's handy for the reporting. And I think that's I show partly that we have a bit rearranged our selector menu, added some recognition new conditions. I have showed you an example of getting all members on a beam section. I think that's from my side. I think that's it. That's all the improvements. So we are happy to hear your feedback on what was done, and if you want, you can send a message in chat or ask a question about the required feature, or send an email after the demonstration. And now I think I will pass words to Oleg, and he will show you what we are going to do next year.
Yeah, I also made some notes, because for me some of these features were also new. I never heard of this. Yeah, to summarize, what I heard is, first of all, it's the integration into the mechanical tree, which looks great. We will also have the separate modules for only the checks you will need. I saw that we will have the DNV stiffener buckling now. And what was impressive for me, what I didn't know, is the highlight feature. Highlighting the items within a table looks nice, and it will help us within our own consultancy a lot. So I think it's a great feature. The calculation details. So now you can explain to somebody how did you calculate this and see the numbers. Filtering for tables and labels for plots, which will help to present the results. I see that I was asked about the recognition of sections on beams recently, so I think it's great also for some jacketed structures, for example, to prepare everything within your report. I have a question if it's possible, Jarko, to select not only within one plane, but for example, to recognize several or group some sections. I mean, not only one coordinate, but for example, from 1 meter to 3 meters.
Limited now, it's only works by coordinates in one plane. Rest, if you have some inclined beams, they will be put automatically into the custom section. But if you want, you can limit that, because
can I create a component of the beam sections together? For example, 2 sections which are close by.
You can do that from the list.
Okay.
Let me find them again, because I haven't stored. If you create a component, you can choose beam section from the list.
Okay.
You can view them. If you want to limit them, you have a rule of coordinate, for example, and you can say that you want to have them below 5, for example, and that will, I don't know if I put the correct coordinate, but it will take those 2 sections and below that. So you can, in our selector, you can combine rules, so you can make some sub-selections if you want.
Perfect, great. And also I've noticed that we have the property plotter now to see what are the properties within your model. We are a bit short on time, so I will switch back to my screen, which is sure. I will also. Okay, do you see my screen now?
Yes, I can see.
Okay, so I will quickly share what is our future plans. And also, if you have any suggestions for the future versions, if you would like to have anything within SDC Verifier, please, tell us now or send us an email if you want to keep it private, send us an email with what features you would like to have. It's nice for us to improve. We want to help you to develop everything you need within our software. So we will add few codes in the future. Next year, it's going to be FKM guidelines for the fatigue. It's going to be SME pressure vessels code, and it's going to be fatigue DVS 1612, which is commonly used in railway industry also. Then we want to add the Open API. It's an application programming interface where user will be able to interact with the program to create some scripts to automate. It's important for automation, so you will be able to automate some of your routine processes and customize it. And we want to have a optimization module to improve your, so it's good to know that your structure is passing or not passing the rules of a standard, but we also want to use SDC Verifier to improve the model and to optimize it, to make it better to pass the rules of the checks. I will quickly run through what are the options for you to try. If you haven't done it yet, you're capable of requesting the trial license. It's done through the licensing manager within the software, so you have to download it and ask for trial. We have a lot of tutorials, models for which Jarko used for his demonstrations on our website, so go to sdcverifier.com for tutorials, step-by-step explanation how to do different things within our software. We have a YouTube channel. This recording of this webinar will be also posted on this channel within a day or two. We can do the training in your office, so we offer 2-day live trainings. We can come and help you to integrate SDC Verifier into your engineering process. And that's basically it. This is the contact details of us, and we still have 4 minutes for questions. So if there are any, please don't hesitate to ask, and yeah, don't forget to unmute your microphone to ask questions.
Hi, Oleg and Yako. Thanks for the nice presentation. So this is Ajay from Hyderabad office. So just a quick question. I have joined a bit late, so I'm not sure if it was already told, but I wanted to know if all these options are they implemented in Ansys Mechanical as well, or because you were showing it in FE map?
Yes, everything what was shown will be, it is already implemented within FEMAP, Ansys Mechanical, and SimCenter 3D. So we work on all 3 platforms. So it was, yeah, it is possible to do everything of this on Ansys, and also big benefit for Ansys now is a complete integration into Mechanical Tree. So you
Is that already implemented in 5.3?
yes, it is in 5.3, which will be released in few weeks. Jarko, you know the date.
Yeah,
That's great. Yeah.
Yeah, that's everything is for Ansys available, which was shown. There was 2 improvements for FEMAP, but I forgot to mention. We have added to read material direction results from FEMAP, and also users can choose solid centroid results. I forgot to mention it is on the presentation, so we will share that. The rest is available for Ansys and will be available in 3 weeks in 5.3.
That's great. Yeah. So it would be great if we can receive this presentation through email.
Sure. After the meeting, I will send you the link to the recording. I will send you the slides. If you have any remaining questions, we can arrange a
Sure.
call
Thanks a
or
lot.
reply.
There are more improvements. Not all are included. I think the major are. There are a few more. So I think later when it will be released, we will publish an article with all the improvements on the website as usual.
Yes, yes, yes. I think that will be helpful.
Yeah. Thanks.
Thank you. Thank you.
Okay. Any more questions? Check the chat. I don't see any more questions. So thank you for attending this webinar. Thank you for your time. We will share the recording, we will share the materials, and we will publish the article with new features as soon as the version is released. So if you would like to have the try, don't hesitate to ask for trial. If you're already a user of SDC Verifier, you will also receive an email with notification on the date of the release. We hope you all update to the 5.3 and you're going to be happy about the updates which are published, and we are looking for the feedback from you. We want to help you to develop the features you would like to have. So we are open to the suggestions for the 5.4 and future versions.
Because actually part of the improvements of the highlighting were coming from the customers. So I think, yeah, probably 30% of that. So do not hesitate. If we get an idea, it's easy to implement. We usually go for it.
Yeah.
That highlight feature is one of the example of our customer feedback.
Great. We made it just in an hour, so thank you again for your time, and I hope to hear from you soon. Goodbye.
Yeah. Have a nice day.
Thank you.
Bye.
Thanks a lot. You too. Have a nice day.
Thanks for the nice presentation.